Okay, last one for the day. Medical iodine, radioactive, which means it has a half-life, and you're given the half-life. That means half of the substance will decay into something else in that amount of time, 8.02 days. So half-life is in days. It's kind of like the interest rate. So the units, the time period matters. Patient is injected with 20 milligrams, so that's the starting amount. It's kind of like A sub 0. And you're going to determine to the nearest day. There's your rounding. Notice days match days. And you want to get down to 7. Right, so let's see, after 8 days, if you start with 20, you're down to 10. Another 8 days, the 10 will be cut down to 5. So somewhere between 8 and 16 days should be our result. Right, so to write the formula, it's A sub 0, but the interest rate, since it's a half-life, is decay at 50%. So 1 minus 0.5 is 0.5. So whenever you do half-life, the base is going to come out to be a half. Right? Then you raise it to the number of half-lives you're going to have, but T will be in days, so you take the number of days and you always divide it by how long one half-life is, 8.02. Right, so you take the total number of time and you divide it into how many chunks of 8.02 you have, and that's how many times you'll multiply the original amount by 1/2. So I know the original amount for this one is 20, so the amount I have at any given time is 20 times 1/2 raised to the T divided by 8.02. That's always what your half-life formula is going to look like. Right, so I want to know when that's going to come down to be 7. And lo and behold, we have another exponential equation to solve. So the first thing I want to do is get a number equal to the base raised to the exponent. So in this case, I'm going to divide by 20. And when I do that, I get 0.35 equals 1/2 to the T 8.02. Now I have a base raised to a power equals the result. Turn it into a log. The log base 1/2 of my result, that's the input, gives me whatever exponent I had. Base, the result of raising to a power, and the exponent I used. This is a number. Take out my calculator. Math. Log base 1/2, 0.35. Get that number right there. So 1.5145 ... equals T over 8.02. Think about this as like being over 1, cross multiply. I'm going to multiply this entire number by 8.02 and get 12.1468. Nearest day, 12 days. So that equals 12 days. Now if I want, this doesn't say solve algebraically, So if I wanted to, I could just find where these two, each side of the equation is equal. So if I go back to this guy right here, I want to know when this is equal to 7. So y equals, I'll put in 20 times 0.5 raised to the x divided by 8.02, and I want to know when that is equal to 7. So window, let's see, I figured it'd be somewhere between 1 and 2 half-lives. So, you know, if I want 8, but just to show the beginning, I'll go out to 16. That's almost 2 half-lives. And now I'll do a zoom fit. There's the exponential decay. And there's my horizontal line, y equals 7. I did put in 7, right? I did. Okay. Second calc. Intersect. Get the crosshairs close. Hit enter 3 times. 12.146877. There it is, right there. Cool.